Okay, in this question we have a DC motor. So we are asked which change does not increase the turning effect of the coil. Okay, option A, by increasing the diameter of the wire used, we will decrease the resistance, and when we decrease the resistance, the current will increase. A larger current will bring about a larger turning effect. So A will increase the turning effect. Okay, so A is not the answer. Okay, B, increasing the supply voltage, this will increase the current. So increasing the current will increase the turning effect as well. So this is not the answer. Okay, removing the soft iron cylinder. Okay, we have to bear in mind that the soft iron cylinder is used to concentrate the magnetic field lines across the magnet. So if you were to remove it, the magnetic field strength that the wire is experiencing, it will be lesser. So this will bring about a decrease in the turning effect. So option C is the answer. And just look at option D. Using a stronger magnet will increase the magnetic field strength experienced by the wire. So this will also increase the turning effect. So this is not the answer. So the answer is C. Okay, we have a beam of electrons that is entering a magnetic field region. So what is the effect of the magnetic field on the electrons? You can use the Fleming's left-hand rule. Okay, since the direction of the electrons is to the right, that means the current is going to the left, and the magnetic field is pointing downwards. We direct our index finger downwards. You can see that our thumb is actually pointing out of the paper. Okay, so it will cause the electrons to be deflected out of the plane of the diagram. So the answer is B. Okay, in this question, right, if you were to push in the North Pole, a current will be induced in the direction such that it will produce a pole here to oppose the change. So since this North Pole is coming in, right, the current flows in the direction such that it will induce a North Pole here to push out the North Pole. Okay, so inducing a North Pole at position Q is going to give us a deflection to the right. So we look at the four options and see which one will induce a North Pole at position Q, and that will be the answer. Okay, so if we were to pull the N pole out from position Q, okay, in order to oppose the change, we are going to pull it back. So we need a south at Q. Okay, so this is not the answer. Okay, by pulling the S pole out from the NP. So in order to pull the S pole out from the NP, NP is going to induce a North Pole here to pull it back. So at Q is going to form a S pole. So B is not the answer as well. Okay, for C, pushing the N pole into NP. So if you try to push a north into NP, NP is going to react with a North Pole so as to oppose the change. So it will form a South Pole at NQ. So this is not the answer as well. Okay, if you try to push a South Pole into NP, right? Okay, let's say we have a South Pole that is pushing into NP. NP will oppose it with a S pole. That means on the Q side, right, it's going to be a N pole. So now we have an N pole similar to the original case. It's going to give the same deflection to the right. So D is the answer. Okay, in this question, we are given the output voltage versus time graph of an AC generator. So we are told that the coil in the generator rotates 20 times in 1 second. So the frequency is equal to 20 Hertz. And the period it will be 1/20. This is going to give us 0.05 seconds. That is why we see that a complete cycle is formed in 0.05 seconds. Okay, so now the speed of rotation of the coil steadily increases. What will happen to the output changes? Okay, first of all, if the speed of rotation increases, we should expect the frequency to increase, and the period will get shorter and shorter. And the other change that we expect to see, right, is that since the speed of rotation increases, the rate of change of magnetic line of force linking the circuit will increase, and this will give us a larger and larger output voltage. Okay, so now we look at the option. The answer should be option D. Okay, because we can see that the period for each wave cycle, it decreases. That means the frequency is increasing, okay, and the amplitude of the wave actually increases gradually. Okay, so the answer is D. Okay, since the transformer is 100% efficient, that means the power in the secondary coil is equal to the power in the primary coil. So voltage in the primary coil multiplied by the current in the primary coil is equal to the voltage in the secondary coil multiplied by the current in the secondary coil. So with this, we just plug in the value. The voltage at primary coil is 40, the current is 0.5, voltage at secondary coil is 2, and the current in secondary coil can be calculated as 40 multiplied by 0.5 divided by 2. This will give us 10 ampere. Answer D.